Solving projectile motion, example number 1. The first step to solving all of the problems that we've ever done has been to pull out the given information. By reading through our problem here, we know that we have a cliff that is 80 meters high, which we'll identify as delta y. We also have a projectile that we shot from horizontally, which we'll say is Vx, at a speed of 25 meters per second. Now, our first question asks us to find how long it takes for our projectile to hit the ground. So due to what we know, we can use our delta y is equal to 1/2 gt squared equation. We just need to reorganize that to solve for t. By setting up our equation as the square root of 2 delta y over g, we can solve to find the time that it takes for our projectile to hit the ground. Since we know that our delta y is 80 meters, 2 times 80 meters would give us 160 meters, divided by the value for little g, which was 10 meters per second squared. 160 divided by 10 would leave us with a value underneath the square root of 16 seconds squared. And the square root of 16 seconds is 4 seconds. Now that we know the time that it takes for our projectile to hit the ground, we can determine its position at each second along the way. By doing that, all we need to know is the time. So we can fill in our chart here with just the times at 1 second, 2 seconds, 3 seconds, and 4 seconds. Now, based on the time and the other given information that we have, we can find the distance that our projectile travels horizontally using our standard Vx is equal to delta x over t equation and rearranging it to solve for delta x. To solve for delta y, we again only need the time, but we don't need to reorganize our equation in any way, shape, or form because it's already set up to solve for delta y. By using the values of our time and plugging those back into both equations, we can solve to find the distance that our projectile travels both horizontally and vertically in each second. By plugging in our time into our horizontal distance equation, our delta x is equal to Vx times t, we know that our projectile travels 25 meters in the first second, and after 2 seconds has gone a total distance of 50 meters, after 3 seconds 75 meters, and after the 4th second 100 meters. Now, vertically, as we plug in our information, delta y is 5 meters after the first second, after the second second it is 20 meters, after the third second it is 45 meters, and then after the 4th second it is a total distance of 80 meters. Once you have that information, you can plot the path of your projectile with and without gravity. By looking at our chart, we know that the scale on which our chart has been created is 1 block is equal to 5 meters. Now, we will use the red dots to show the path of a projectile without the use of gravity. Without having gravity, our projectile would never fall towards the ground, so it would just travel in a straight line, covering 25 meters in every second. So in looking at our chart that we're plotting, we would start at the edge of our cliff and continue out 5 blocks, or 25 meters, each time, leaving a red dot along the way. That would show us the path that a projectile would take if it did not encounter any gravity along the way. Now, plotting the path of the projectile with gravity is slightly more complicated. We'll use the blue dots to show that path. Your projectile will begin in the exact same spot that it did if there was no gravity. However, now, in addition to our projectile moving out horizontally, it also moves down. So after 1 second, it's moved out 25 meters and down 5 meters. After 2 seconds, it's out a total of 50 from the cliff and down 20 meters. After 3 seconds, it has gone out a distance of 75 meters and down a total of 45 meters. And then after 4 seconds, it's out a horizontal distance of 100 meters and down a distance of 80 meters. The final step in plotting the path of your projectile is just to connect the dots. This will show a smooth line that plots the path of the projectile as it would continue. Try your best when plotting the projectile with gravity to make it a smooth curve and not just connect the dots using a ruler. If you have questions, please post them on the class website. That way I can get back to you and answer them.